So hello everyone, welcome back to Algo Daily. In this particular video, we are discussing LeetCode Weekly Contest 437 problem number B. And in this problem, we have to given an integer array of pizzas of size n, where pizzas of I represent the weight of the ith pizza and every day. And you eat exactly 4 pizzas due to your incredible metabolism. And when you eat pizzas of weights of w, x, y and z, and these are our conditions, and you gain the weight of only one pizza, and we have to given odd numbered days and the even numbered days, and after that we have to find the maximum total weights that you can gain by eating all pizzas optimally. And so now let's look at their problem statement, and then we have to discuss their example test cases so that you can understand how actually we have to work on their uh, actually we have to find their maximum total weight. And so here firstly we have to given the the pizza and their values. And so once again, so we have to given pizzas and their pizzas of I. This I represent their ith index of their pizza, and we have their given their weights or as well as, and this odd numbered means like odd number days. The heaviest pizza among all the four determines the weight gain that day. And also we have to given the even number, and this even number means the even number days the second heaviest pizza among all the four determines weight gain. And our task is to find the maximum total weight gain after eating all pizzas. Okay, so the key observation of this question is, first we have, since n number, and this n number is always multiple of 4, and this always multiple of 4 means we can divide the pizza into complete 4 groups. Okay, 4 groups, and these 4 groups, the order of which we can eat the pizza matters, as it affects the weight gained each day. And we have to given this problem statement, and then we have to find their maximum total weight which is gained by eating all pizzas optimally. Okay, and now the highlighted things are like here the pizzas is basically represent the array of integers where you can where each element is the weight of their like distributed pizza, you can say. And also here we have to given exactly 4 pizzas. It means exactly 4 pizzas per day means like every day you must eat exactly 4 pizzas, no more and no less. And also we have given the metabolism, this metabolism of w, x, y and z. It means we have to pick 4 pizzas and sort them in increasing order. Like increasing order means w, x, y and z, and this is our increasing order. And then odd number of days you can gain this z means this z is our heaviest pizza, and this y, and this y is our like second heaviest. Okay, second heaviest pizza, and this is gained by y. Okay, and now after that we have to find the maximum total weight you can gain. Like we need to arrange the eating order optimally to maximize the total number of weight gain. And so now let's look at their example test cases. So in this example we have to given the pizzas, and this is our array form 1 2 3 4 5 6 and 7 and 8. And so now let's sort this pizza. So basically this is a sorted order, but when if it is unsorted, then we have to sort them first, then we have to find their second heaviest and heaviest. Okay, so now we have to split into 2 days. And so why 2 days? The day 1, this day 1 is our odd, and this second day 2 is our even. And this odd is basically for we have to pick 4 heaviest remaining pizzas. So 4 heaviest remaining pizzas means we have their like first 2 3 5 and 8, and the second the weight gain by this one is this weight gain because of 2, 3, 5 and 8, it means this is odd, and the even one is 4, 1, 1, 4, 6 and 7, and so this one is even. And so now highest weight gain by using this one is we have their values. So basically this odd one is 8 is our weight gain. Okay, and here weight gain is 1, 4, 6 and 7, so the second one is 6. Okay, so the total weight gain is 8 plus 6 is equal to 14. Okay, so 14 is our answer. So now let's look at their example second, so that you can understand how actually we have to get these values. Okay, so now here we have their values of 2, 1, 1, 1, 1, 1, 1 and 1. Okay, 3, 4, 5, 6. So now here first we have to sort the pizzas and sort them, and after sort 1 and this one. Okay, and after sort we have to get these values, and so now the day one is our odd, so we have to pick this 1, 1, 1 and 2, and this day 2 is basically for even for 1, 1, 1 and 1, and here we have maximum weight gain 2, and here is 1. You can say here is 1. Okay, and so total is 2 plus 1 is equal to 3, so 3 is our answer. So I hope you understand the logic and the example test cases, why we have to take these values. Like first we have to take heaviest, then we have to second heaviest. Okay, and then we have to find their maximum value, and I hope you understand the iteration, like how we have to achieve the values, and like, and then now let's look at their approach of this problem. So how we can optimally find the ways, like how we find the total maximum weight. Okay, so first we have to look the constraint. Okay, so here we have to given this constraint of 4 less than is equal to 10, 4 less than is equal to n is equal to pizza dot length, and then we have there 2 into 10 to the power 5. So here we have there we have given 2 into 10 to the power 5 means 20, this one. Okay, 1, 2, 3, 4, 1, 2, 3, 4. Okay, and this one, and then we have there n is suggest for n log n form. We have to achieve this time complexity, and now this 1 less than is equal to pizza dot I less than is equal to 10 to the power 5, and then we have to given 10, n is multiple of 4, and 4 is our basically for 4 we have to cut them out. Okay, and so now sorting is feasible for this one, like we have to sort them, and then we have to sorting is like O of n log n, and this O of n log n is can be like 20,000, and now we have to pick select the elements optimally. Like first we have to pick, one second, first we have to pick, and this pick basically for we have to pick z for max or days, and this pick of y, and this pick of y means we have to second max calculate here, and then we have to get after sorting we have to get their time complexity of O of n log n. And now let's look at their coding implementation part. And so this is a simple coding, like why we have to use this sorting I already mentioned here, like on our example test cases. And so this sorting is ensure that we have to always pick the heaviest available pizza first, and then we have to move further. And so now here we have to iterate through n plus 7 by 8, n plus 7 by 8, it means we have there uh, find the elements with z with their heaviest pizza. Okay, and so now why we have to take n by 7 by 8, it means we have and the key idea of this one is we have to try and select the heaviest pizza first, and then why we have to add 7, and this 7 add, because of we have there n by 7 by 8, ensure that we have to correct rounding for small values of n, making sure like we have always select the correct number of element, and then we have to take this n plus 7 by 8. Okay, and now this why we have to iterate with this loop. We have to find the maximum pizza, like maximum weight pizza object with odd numbered. Okay, so that we have to calculate here, and then after this we have their calculation here, and this main calculation of we have to finding here y, and this y is basically for second heaviest pizza for even days, and it start from n plus 7 by 8, and this is the calculation, basically simple calculation. And why we have to take this one, this pizza of n plus 7 by 8 plus I into 2 plus 1 is basically for n by like n plus 7 by 8 means we have skipped the element already used in the for loop, like here we have to already calculate here, so that's why we have to exclude here, and then I into 2 plus 1, it basically means we have to move the step of 2 steps of 2 of to pick the y, because we have to find their second heaviest pizza. And now why we have to why we have to use this loop is basically for we have to pick the second heaviest pizza of the y even number days. Okay, and then we have to return their answer, like first we have their first heaviest and then second heaviest, and this first heaviest pizza we have to take this calculation of n by 7 by 8, and then second heaviest we have to calculate by n by 7, no sorry, n plus 7 by 8. It means we have already calculated this heaviest pizza, then we have to further and then we have to further look their second heaviest pizza, and this one is basically for we have to get like let's suppose we have, and this one is basically for z and this is basically for y. Okay, and then we have to calculate with their answer, and then we have to return their answer. And now I hope you understand the logic and the implementation part. And so now let's drive in their example test case so that you can understand how we achieve this coding solution basically. So the now we have to take the first example, 1 2 3 4 5 6 7 8. Okay, and after sort we have this sorting. Okay, and we have sorting in descending order, and after descending order 8 7 6 5 4 3 2 and 1, and after this we have their first loop for odd days. We have their odd days we have to calculate here, and odd days we have n plus 7 by 8. It becomes 8 by 7 by 8 is equal to 1, and after this we have their, we have to pick the pizza of 0 is equal to 8, and total weight gained by 8. Okay, here we have to calculate 8, and then we have their second loop. Okay, and this second loop we have their find the second heaviest pizza, and the second heaviest pizza we have their even days. Okay, and here even days, and this even days we have to calculate with the n by 8 is equal to 8 by 8 is equal to 1, and we have to pick the value, and here we have to pick the pizza of 8 plus 7 by 8 plus 0 into 2 plus 1 is equal to pizza of 2 is equal to 6, and this 6 we have to calculate the value, like the calculated value we have to calculate here, and then what we have to get, 8 plus 6 is equal to 14. So this is our answer. So I hope you understand the logic and the implementation part, so how we calculate this formula here. And so now the time complexity of this code is we have to sorting the steps by using O of n log n solution, and then the loop iteration we have O of n, and then overall time complexity of this code is O of n log n plus n is equal to O of n log n. This is our final time complexity, and the space complexity of this code is O of 1, because we have not declaring any operations, any values here, so that's why we have O of 1 space complexity of this code. So I hope you understand the logic and the implementation part of this code. So thank you everyone. Thank you so much.